Okay, your power notes today are titled Linear Equations and Functions. And our essential question is, why are the answers to an equation on the line? Well, we're going to see in a moment why that's true. So one of the things I need you to learn about is called a table of values and what that looks like. So you've seen these before, especially last year, and they can either go up and down or side to side. We're not going to use the side to side one. The side to side one is used primarily for finding an equation. They'll put some numbers in there and you have to find an equation, the relationship. And we use the one going up and down when we're going to be graphing. The reason we use this one is because it can conveniently make an ordered pair for us. And we can see that right there, and then it would be easier to graph. So that's kind of why we use the up and down one. So let's graph one so that we can see how this all works. So for example 1, we're going to graph 3x minus 2y equals 6. When we graph and we use a table of values, you want to make sure that you use 3 simple numbers for x. And I'm going to put them in colors here so it will be easier for you to see my work. We're going to use the numbers 0, 1, and 2. Those are always the numbers we're going to use no matter what. And the reason we're going to use that is because since they're the most simplest numbers, that will help us to plug in and see what's going on. So let's first do 0. If I put 0 in, I get 3 times 0 minus 2y equals 6. So I'm going to start to solve for y. Now I have one variable. I'm going to get rid of this 3 times 0 because 3 times 0 is 0. And just solve from here. So this will be divided by negative 2. And I find out that y equals negative 3. So I'm going to put a negative 3 in there. Alright, now this time I'm going to try it with a 1. So I'm going to put a 1 in there. 3 times 1 minus 2y equals 6. And I'm going to do the math. 3 times 1 is 3. Write it out. Now I'm going to start solving for the y. So I'm going to subtract 3 from both sides. 6 minus 3 is 3. And I'm going to divide both sides by negative 2. And I get negative 3 halves. Now, it's okay to get a fraction. That happens sometimes. And that's okay. We can graph that. That's negative 1.5. So I'm not too concerned. And let's do the last one. Let's put 2 in there. So 3 times 2 minus 2y equals 6. 3 times 2 is 6. Subtract 6 from both sides. Negative 2y equals 6 minus 6 is 0. So negative 2 times something equals 0 tells us that that something is 0. So we'll put a 0 here. So now what we're going to do is plot these on our coordinate plane. So let's start with this 0, negative 3. Remember this pair, this is the x, where you're going to move on the x, this is where you're going to move on the y. Remember this is called a coordinate plane, and the origin is in the middle, and we always start in the middle. So we're going to do 0, negative 3. 0 doesn't mean we're moving anywhere on the x, but we're going to go down negative 3 on the y. And that's where that one's going to go. Okay, going back to the origin, we're going to this point 1, negative 3 halves. So I'm going to go positive 1 on the x, and then down 1.5. Estimate it right there. And then this last one, 2, 0. Again, starting from the origin, I'm going to go 2 on the x-axis and then go 0, not move, on the y. So you can see how they all line up. You want them to line up, because when they line up, that way you know that that's your line. If they don't line up, you did some math wrong, or you may have plotted wrong, so you might want to go back and check. That's why we pick 3 points. And you draw a line through it. When you draw your line, make sure you extend it through your points, not just to cover your points, but through them, so that even though you have these 3 points on your line, right? 1, 2, 3. Even though we have 3 points on the line, every single number here, any number that I go through, is a solution. Okay? So we've got to be able to cover all of it. Everything in between, the fractions and everything. So when we talk about that's where we find all the solutions are on the line. We're not going to find the solutions out here. There are millions of solutions for an equation in 2 variables. We just got to draw that line to show what's going on. Okay, so let's put a little bit of thought to something here. So when there are two variables, the line's angled. Okay, so that means we have an x and a y, and that means we're going to have an angled line, whether it goes up or it goes down. We're going to have some kind of angled line. So what happens when there's only one variable? Okay, that's what we're going to work on right now. Okay, so when there's only one variable, I think we're going to have to, there we go here, y equals 5. Okay, so when we have y equals 5, we notice that there's no x at all in the equation. If there's no x, it does not touch the x-axis. We notice because this had an x and a y, it was going to touch the x and the y-axis. This one's not going to. It has to have that variable in there in order to touch it. So when we're looking at what that looks like, it's going to give us a horizontal line. Okay, so we're going right through the 5, and we're going right through it. It's going to give us a horizontal line. Okay, so let's think about what x equals 2 does for us. X equals 2, there's no y. So if we go to our graph and put x equals 2, it lands right there. And if it's not going to touch the y-axis because there's no y whatsoever, okay, we're going to get us a vertical line. Okay, going right through 2. So we now know that when there's two variables, we're going to get that angled line. And when there's only one variable, we're going to get a either horizontal or vertical line. And I know it doesn't seem like it makes sense. When you have x equals 2, it's going up and down. It looks like the y-axis, but that's kind of the way it is because we don't want to touch the y. The only time it's going to touch the y-axis, and let me show you that, is if I put it there, right? And then it touches the y-axis, but that's where x equals 0, isn't it? So that kind of helps a little bit to figure out which way things go. All right, let's talk a little bit more about solutions. So let's go to example number 2 and write down x plus 5y equals 3. And we're going to determine whether negative 2, 1 is a solution. Now, we could go through what we just did in example 1 and graph it and draw all those things to find out and see if it's on the line, but there's an easier way. And the easier way is this. Since this is an ordered pair, that's what we call this, an ordered pair, one is going to be x, the other is going to be y. We can take these values for x and y and replace them in the equation to see if it's true. So if I take that and replace it, I would get negative 2 plus 5 times 1 equals 3. So all I have to do is follow the order of operations. Just do that. Negative 2 plus 5 equals 3. Negative 2 plus 5 is 3. So since both sides are equal, this negative 2, 1, this ordered pair is a solution. So we're going to say yes, it is. And this is our proof to show that yes, this is a solution. And again, it's important to have proof to explain why you're saying what you're saying. Okay, let's try it again. This time let's use the point 4, negative 1 and find out if that is a solution. And again, this is the x, this is the y, and we're just going to replace. So we're going to write 4 plus 5 times negative 1 equals 3. And we're going to do again the order of operations and follow along. So the 4 stays, 5 and a negative 1 is negative 5 equals 3. 4 minus 5 is negative 1. So this is not equal. This is not going to work out. So this point's not on the line. No, it's not. Not a solution. So we can sometimes use algebra to find if something is a solution or not. We don't necessarily have to go through plotting it all and getting a t-table and looking to see if that's on the line. There are easier ways. Okay, on your paper it talks about standard form. And standard form is when you have this format. Let's take a look at the format. ax plus by equals c. You will notice that the x and the y are on the left side of the equation. The c is the constant. Okay, so we have an x and we have a y and then the number by itself. Now you'll notice this a, b, and c. Let's talk about what a, b, and c are. A is a whole number. Okay, and if we remember from our chapter 1 vocabulary, A whole number is 0 and any regular number after that. All the counting numbers, all the natural numbers. So 0, 1, 2, 3, so on. Okay, so that's what A has to be. Okay, now B and C, on the other hand, they're integers. Again, thinking back to our chapter 1 vocabulary, an integer not only is 0, 1, 2, 3, etc., but it's also -1, -2, -3, etc., going that way. Okay, there's no fractions and there's no decimals. So if we get the fractions or the decimals, we have to remember about what we learned about clearing in chapter 2. We want to get rid of the fraction or get rid of the decimal. We're not allowed to have that. So let's take a look at example 3 here, where it says y equals x plus 3. And let's see if we can get this into standard form. Now, when we look at this, the problem is that the x is on the wrong side. I need the x to be on the other side. So when we don't want something, we use inverse operations. So this is a positive x. Let's subtract an x from both sides. We do that, and we end up with -x plus y equals 3. Now you would think we could stop, but we have a small problem. Our problem is we cannot have a -x, remember, because a is a whole number, and -1 is not a whole number. So how do we get rid of -1? We have two choices. Either we multiply by -1 through every single term, or we divide. I like dividing because it looks cleaner. Doesn't matter which one you choose. And then you rewrite it. And all that does is change the signs of everything. Take a look at the difference between this top green equation and this bottom one, what it does. It went from a -x to a positive x, a positive y to a negative y, a positive 3 to a negative 3. So now we're in standard form. We have no fractions, no decimals. Our x and y are in order. There's a is a whole number, it's 1, and so we're good to go. We're going to practice this a couple of times because this seems to be a difficult concept for some people. So let's take a look over here at number 4. And number 4 says y plus 9x equals 0. Yeah, everything is on the left side, but we've got a problem here. The x and the y are in the wrong places. So what we need to do is use the commutative property and just switch them around. 9x plus y equals 0. Now we're in the right order. Standard form has a certain order to it, and that's kind of what we're practicing. Just getting things in that order. Okay, let's see. Here's example 5. Y equals -1/4 x minus 3. And we have a fraction, so that's going to be a problem. So let's get rid of the fraction first. Since it has a denominator of 4, we're going to multiply everything by 4. So 4, 4, 4. Okay? Multiply everything by 4. And what this does for us is helps us get rid of this fraction, right? So 4 times y is 4y. Bring the equal sign down. Now the 4's go away, but that negative sign didn't go away, so just leave it with it. Minus 3 times 4 is 12. Again, we have the x on the wrong side. So if we add x to both sides, we now will have x plus 4y equals -12. And again, we have a whole number out here in front of the x. Everything else is good to go. Now, I know some people saw that negative and thought, oh, let's multiply by -4. You don't have to. Wait until you see what happens. You'll see we didn't need to multiply by a negative. It came into place all the way through. I have one more for us to try. And this one is x equals 3y plus 1/2. Again, we want to get rid of that fraction. So we have a denominator of 2. So let's multiply everything by 2. And then we're going to rewrite. We'll have 2x equals 3 times 2 is 6, and the y comes with us. Plus, now these 2's go away, 1. Again, we got the x on the right side, but the y's not there yet, so let's subtract 6y from both sides. Remember, when we do it to both sides, it shows the property of equality. We want to keep everything in balance. Equals 1. And again, we have 2, whole number, we're good to go, so this is in standard form. That's the end of our notes. Oops.